A 2-gram bullet moving at 538 meters per second strikes a 0.25 kilogram piece of wood at rest on a frictionless table, one of those magical frictionless tables. The bullet strikes in the wood and or sticks in the wood, and the combined mass moves slowly down the table. Find the speed of the bullet block after the collision, and use momentum to do that. And then find the kinetic energy of the system before the collision. That should be pretty easy. Part C, find the kinetic energy of the system after the collision. And then part D, what percentage of the kinetic energy is lost? Okay, so let's do this here. We'll make this given. So here's a drawing of it. So this bullet has a mass of 2 grams. We'll make that 0.002 kilograms. And it has an initial velocity of 538 meters per second. Now this guy is not moving. This guy has a mass of 0.250 kilograms, and initially the block's not moving. And we want to find, okay, for A, the final velocity of these two guys after the collision, and then B, the kinetic energy before the collision. So I'll just call it KB for before. And then C, find the kinetic energy of the system after the collision. I'll call that, well, you know what? Instead of before, I'll call it initial. Or before the collision is the initial kinetic energy. There's my final kinetic energy. And D, I want to know, well, it's delta K over K, initial, times 100%. This will be the percentage of kinetic energy lost. Hope you can see it from all the way back there. I'll write bigger up here. Okay, so let's solve it. For part A, P initial equals P final. This is a collision problem. You can't forget that old stuff. Physics builds on itself. So the initial momentum is just the momentum of the bullet. So we can say it's the mass of the bullet times its velocity. Let's go ahead and I'll just plug in the numbers to save time. 0.002 kilograms times its initial velocity, 538 meters per second, equals the final momentum. Well, you just have to add these two masses together because they're moving together, right? After the collision, it's the total mass, so that's I have to write smaller here to fit it in, 0.252 kilograms, right, times their final velocity. And so to find that final velocity, you just divide it. So the final velocity is equal to 0.002 kilograms times 538 meters per second divided by 0.252 kilograms. So this is the block and the bullet added together. And so the kilograms cancel. And borrow it back. And so when I calculate it out, let's clear this, I get 0.002 times 538 divided by 0.252, and you get 4.26. Okay, so the final velocity will actually 4.27 if I round it off, or 4.3 if you want. Yeah, well, one significant, yeah, you could. But there's my final velocity. Now, for part B, find the kinetic energy of the system before the collision. K equals 1/2 mv squared. So that's 1/2. Now, how much mass is moving? Just the mass of the bullet. The block is not moving at all. So we'll go 0.002 kilograms times 538 meters per second, but you got to square that. So let's calculate. 0.002 divided by 2 is 0.001 times 538 to the power of 2 equals, and the initial kinetic energy should be 289 joules. You agree with that? Okay. Now part C, the final kinetic energy is just 1/2 of 0.242 kilograms. That's the total mass, right? The bullet plus the block. Did I do that right? 252, I'm sorry. Times this velocity squared. And so our final kinetic energy will be 0.5 times 0.252 times 4.27 squared, and you get 2.30 joules. Right? Correct? You agree with that? Okay. Now for part D, it's K final minus K initial. To figure out the percentage that was lost, over K initial times 100%. So K final is 2.30 joules minus 289 joules divided by 289 joules times 100%. So, let's see, 2.3, I already got it in there, minus 289 divided by 289, and then 100 times 100. And you get negative 99.2. Is that right? You don't really need the negative. What we're saying here, the negative means it was lost. The K final was smaller than K initial. So we can say that 99.2% was lost. And what did it do? How was it lost? How do you lose kinetic energy in this problem? It became heat. If you were to take a look at this block, like after you shoot a bullet into a block, if the hole's big enough, you can stick your finger in there and try to feel the bullet. The bullet will be really, really hot. Probably burn your finger. So it heated up the environment. So that's where it went. So that is the whole solution. So the point here is that when a bullet and a block hit, momentum is conserved. But look, the kinetic energy is not conserved. That makes this what kind of collision when kinetic energy is lost? It's an inelastic collision, and in this case, a lot of it was lost. You know, almost all of it. That is all.